So we're doing problem 8, and we're starting with part A, where we're trying to find what the current is and in what direction the current goes. So we know that current will flow from positive to negative on the battery. So we know the current is going clockwise. So we have current in this direction. So in order to find what the current is, we need to start by finding what the resistance is. And to find resistance, we know that we find it's the resistivity times the length of the resistor divided by the area. And the area is just a cross-sectional area. So in our case, it will just be the top of our cylinder, and it will be pi r squared. So now that we know what our resistance is, we can now find the current by using the equation I equals delta V over R. So we were given the delta V in the problem, which is 4.5 V. So we have 4.5 V, and then we divide it by a resistance of 1.79 ohms, and that gives us 2.51 amps clockwise, given that that's how the current is moving.
For part B of this problem, we are first interested in determining the direction that the electrons flow through our resistor in this circuit. We know that current is the flow of positive charges through the circuit, so therefore the electrons are going to go opposite the current or counterclockwise, as such. For the next part of this question, we are now interested in determining the number of electrons that flow through our resistor per second. So we know that we found the current to be 2.51 amps. We know that current can be written as also the change in charge over change in time, or coulombs per second. So if we divide this by the charge of an electron, which is 1.6 times 10 to the negative 19 coulombs, we will be left with the number of electrons per second, which is 1.57 times 10 to the 19.
So the last part of this question is asking about the magnitude of the electric field strength flowing through this circuit. So we know that the magnitude of electric field is equal to negative change in voltage over the change in distance. We know the change in distance, which is given by the length of our resistor, which is going to be 1.5 times 10 to the negative 2 meters. And we know the change in voltage based on the fact that the resistor is in parallel with the battery, which is going to be negative 4.5 volts. That cancels out the negative in front of the equation, leaving us with 300 volts per meter as the magnitude of our electric field.